Hello students, we are going to do the first practical of physics, that is to determine the resistivity of two wires by plotting a graph for potential difference versus current. There is another practical which tells us to find us the resistance per centimeter of a given wire by plotting V versus I graph. So both the practicals are more or less the same. So we know about the basic apparatus that we shall be requiring here will be a metallic conductor, a battery, a one-way key, a voltmeter, an ammeter of appropriate range, connecting wires, a piece of sandpaper and a scale. The purpose of the scale will be to measure the length of the wire. We shall also be requiring another instrument, that is a screw gauge. The formula that we shall be using is, we know that R is equal to rho L by A. So rho will become equal to R into A upon L. With the help of the scale, we shall be measuring the length. So take it approximately to be about 40 or 50 centimeters. Then to find the area, we know that area is equal to pi d square upon 4. Now to find the diameter, there is again an unknown quantity involved here, that is the diameter. To find the diameter, we shall be using the instrument called screw gauge. The least count of screw gauge is 1/100th of a millimeter. So it's basically equal to, the least count is equal to 0.01 millimeter. So to find the diameter, first we shall be taking the main scale reading of the screw gauge, and post that we shall be dividing that millimeter into 100 parts, and then we shall be taking the next reading, which is not on the main scale, the vernier scale reading. And that is how we shall be approximately finding out the diameter. We shall be taking 3 such readings on 3 different cross sections of the wire, and then we shall be taking a mean of it. So 3 readings of the diameter at 3 different cross sections of the wire, and then we shall be taking an average of it, because it might be that the wire is not perfectly uniform and there might be some error involved. So to minimize the error, we shall be taking 3 readings of the diameter using the screw gauge and taking an average of it. That is the first thing you will do. You will measure the length, L is known. You will measure the diameter at 3 different cross sections, and we will be using the formula A is equal to pi d square by 4, and with that we will be able to solve L, A. But now the only quantity that is left out to be found is resistance. So how do we find the resistance? To find the resistance, we shall be using the apparatus as shown here. I shall also be demonstrating in the further part of the lecture how the connections are made and how to take the readings on the voltmeter and ammeter. But this is the basic circuit involved, the one which is shown here. A voltmeter, an ammeter. Obviously the ammeter is connected in series. Then we have the wire of unknown resistance, whose resistance is to be found out as R, which is connected in parallel with the voltmeter. Then we have a rheostat, and then we have a key. So when we'll switch on the key, the circuit will become functional. And some things that you have to note before taking the readings is the errors on the ammeter and voltmeter, and also their least count. So and you should also see if the ammeter is taken in milliamperes and the voltmeter is taken in millivolts, but generally we shall be using a voltmeter which is measuring the voltage in volts, and an ammeter which is measuring the current in milliampere, so that we get sufficient good readings and the readings are not too small to be noted, and 0 errors are to be taken care of. Also, we know the least count of the screw gauge, we have already mentioned, it is 0.01 millimeter. Now what we are going to do is, we are going to plot a V versus I graph or I versus V graph and find the slope of VI graph by taking at least 3 to 4 readings. 5 is good. So take 5 different readings by increasing the voltage, increase the voltage, make a table, increase the voltage, and increase in voltage will lead to increase in current. Note down the ammeter readings, note down the voltmeter readings, plot a graph, a V versus I graph. You shall be getting a straight V versus I graph, which shows that this follows the Ohm's law also. And the slope of VI graph, that is V2 minus V1 upon I2 minus I1, will correspond to, we know the formula for slope is what? Y2 minus Y1 upon X2 minus X1. If we are plotting potential on the y-axis, then it becomes V2 minus V1 upon I2 minus I1, which is equal to delta V upon delta I, and which gives you resistance. So the slope of VI graph will give you the resistance. Why did we find resistance? Because we needed to find the resistivity of the wire. A was found out, L was found out, and by plotting the V versus I graph, by taking 5 such readings, we shall be getting the resistance by finding the slope of it. Also, when you have found out, when you have taken these 5 readings, do take an average of it and use the formula R is equal to rho L by A, and the rho will become equal to R into A by L. This you are going to get here as summation of all R's divided by 5 readings you have taken will give you R mean. And then we are going to use the formula rho is equal to R into A by L, where this R is the R mean you have calculated here. Area you have already calculated by using the screw gauge as pi d square by 4. Length you have already measured using the meter scale, and that is how you will be getting resistivity. That is all. Now there are certain precautions that you have to take. There is the voltmeter and ammeter should be of the proper range. It should not happen that you have taken a voltmeter of a bigger range and an ammeter of a bigger range, and when you are increasing the voltage, you are not able to get proper readings or slightly significant readings on the ammeter, because ammeter is not increasing. So we'll take a smaller range of ammeter, that is in milliamperes, that will give you big changes on small increase in voltage, and the connection should be very tight. Rheostat can have high resistance, so you have to take care of choosing a suitable rheostat also. Now you will be asking me, sir, what was the need of using the rheostat? And we already had the voltmeter. By increasing we already had the battery. I'm really sorry. Instead of battery, in our laboratories we are using eliminators these days, battery eliminators. So when you increase the voltage by eliminator, that comes in the range of 2, 4, 6, 8 volts, because of which what will happen, your ammeter, which is the milliampere, which is the milliamp meter, this is MA, okay, this will show very high readings and it will go out of scale. So to prevent that, we are going to slide the rheostat. If you know, the rheostat looks somewhat of this sort, and there is one screw here on this side, the other screw on this side, and there is a slider here. So basically, if I draw a symbolic diagram of a rheostat, it looks something of this sort. So by sliding the rheostat, we are increasing R. When you are increasing R, automatically there is going to be some fall in potential across the rheostat. As there is a fall in potential across the rheostat, the current in the entire circuit is decreasing, because we know R equivalent will increase. One R comes from the wire and the other R is coming from the rheostat. So our main aim was to vary V. Then because of the variation in V, there would have been a variation in I. To vary V, we could have increased the V by the eliminator, but because of doing that, what will happen, that as we are using a milliamp meter, the readings will go out of scale. So what we are doing is we are gradually increasing the resistance of the circuit by, and as more and more resistance is coming into picture because of the rheostat, what will happen is that eventually the current will keep on decreasing, because there will be some fall in potential across the rheostat as well. So V varies, because of which I varies, and we are getting some 5 readings. That's it. That is all for the practical. So the apparatus required is, we'll be taking a meter scale or quarter or semi-meter scale. We'll be having a screw gauge to measure the diameter of the wire. Then we'll be needing an eliminator, an ammeter, a voltmeter, a rheostat. The main function of the rheostat is to increase or decrease the resistance of the circuit, which will eventually reduce the or vary the voltage and current in the circuit. So first what we will be doing, we'll be taking the wire of an unknown resistance, and with the help of screw gauge we are going to take 3 readings at 3 different sections to find the diameter of the wire. The screw gauge measures about 1/100th of a millimeter. Its least count is 1/100th of a millimeter. So we'll take 3 diameters and we'll take an average of it. So we are getting basically the diameter, and which will eventually give us the area, pi d square by 4. Then with the help of the meter scale we'll be measuring the length of it, and by measuring the length we'll be getting the second parameter, which is L, and we have to find the resistivity of the wire by plotting VI graph. So for VI graph we will be taking 3 readings at least, or we can take up to 5 readings also for different values of V and I, when we shall be plotting a graph for V versus I graph, and the slope of the VI graph will eventually give us the resistance of the wire. So resistivity is equal to, rho is equal to R into A by L. A we have already found out by using pi d square by 4. L we have already found out by measuring the length of the wire, and resistance we shall be finding out by plotting a VI graph. The slope of VI graph will give resistance. We'll take 3 to 5 readings and then average it. So I'm just going to show you how to take the readings. So first switch on the eliminator, make it to 2 volts. So you can see we have taken a milliammeter. Be careful about it. You have to measure the least count of milliamp meter also and voltmeter also. We have taken milliamp meter so that we can get clear more bigger divisions or more readings. So first I've kept the battery to 2 volt, and I'm taking the voltmeter reading. It is coming out to be about 0. Each reading is about 0.05. So this comes out to be 5, 6, 7. So it's 7 into 0.05, which is 0.35. So let us start. First reading. So this one is 0.5 and the other comes out to be 60 milliampere. Then I'm reducing the resistance. Now it is about 0.6, and here it is coming out to be about 0.7.
We can take,
and in this way
4 to 5
we shall be taking
readings and draw a V versus I graph and get the value of R. I hope you could understand the experiment, and please like, share and subscribe if you like the content. Also, if you have any doubts, please write in the comment section below. Thank you.